This has been a presentation of SBE 15, New York City.
And thanks to all of you for joining us this evening. We have a presentation to present to you on fiber optics for HD broadcast. I'm Ben Nemser. I'm the CEO of Nemal. Nemal has been manufacturing cables for the broadcast and AV and communications industries for about 40 years from our Miami plant. We work with most of the major networks as well as a wide range of companies from production companies, sports, and other event venues. And we'd like to focus this presentation on the things that we as people in the broadcast industry deal with on a day-to-day basis with fiber. So you have, after a brief video showing our plant with some of the manufacturing equipment with where we make these products, we have a PowerPoint presentation, and then Danny Ritz, who's our VP of Engineering, probably the most knowledgeable person on broadcast cabling that I know of anywhere, will give you a live demo of some of the cleaning techniques and termination procedures that you would use on a day-to-day basis, and then we hopefully will have a couple minutes for some questions. So I'm going to start with the video. Welcome to our plant. There's our Brazil office. That is a 12-channel audio cable going into a DT12 connector. Machining Teflon insulators on our CNC machine. And the planetary cabler. That's the machine we use to build SMPTE cables. Braiding, we'll talk about that briefly. Final extrusion. SMPTE termination, we don't suggest you try this at home. And the finished product ready to plug into your HD camera in your studio. Fiber polishing. And that is our plant, and we would invite you all to come and see us the next time you get to Miami, if you do get to Miami. So we're going to get into our presentation, fiber optics for HD broadcast. We're going to be discussing a number of points: the system concept approach, a brief history of cabling in broadcast and AV, some of the places we use fiber and why in broadcast, look at some of the different types of connectors and cabling that you would see on a day-to-day basis, look at the standards, and then the demo. So we talk about system concept approach, and this is a theme that we continue through this presentation on selecting cabling that is going to work on a system basis, not just looking at an individual link between equipment A and equipment B, but looking at the entire signal path from the origination to the final destination and considering all of the termination points in between. That's critical in an analysis of a new project or a replacement. Now, we've, as long as I've been in this business, which basically goes back about 100 years. We've seen many evolutions in our data rates and our bandwidths, and each one of these has required a change in the cabling and connectors and procedures that we use to connect all of our equipment. So one of the many standards that we've been through, and this one was a quick through, was 3D. You may remember about 10 years ago, 3D was a 6.75 gigabit data rate. A lot of people invested in equipment. It came, it went. Now we're past that, and we're continuing to go past that. But at that point, it looked like it was a real good standard, and we actually got to see the space shuttle launch and film it in 3D for NASA, which was pretty cool. So to put some numbers behind the general idea of copper being, while still useful, much more limited than it used to be, take a look at RG6 and a usable distance. When we start out on the left at a NTSC 143 megabit rate, we get about, well, in meters, it's 544, so about 2,000 feet. By the time we get to 3 gig, we've lost 85% of our distance. By the time we get to 12 gig, there isn't even an entry in the chart. However, there are, you'll notice at the bottom, 3 cables that have specific distance limits stated for 12G. I want to emphasize that being a good engineers, as we all are, I'm sure, we read these charts, we look at these numbers, we figure, well, this should be good for that, and this should last for this many feet. And yes and no, these numbers in many cases are calculated numbers, they're best guesses. They're based upon very specific conditions, perfect temperature, perfect termination, no bends, and single connection points. And you'll also notice at the bottom that there's a lot of caveats, like the bit error rate can vary dramatically as calculated limits are approached. So my point here is, if you're going to use copper in a new installation or with new equipment at some of these higher data rates and bandwidths, you need to be extremely careful. And if you get close to these limits, you may want to consider fiber. The same considerations apply to triaxial cables. The same considerations apply to the connectors that we use in the 3G and higher world. I'm showing this slide just to make the point that if you have to buy BNC connectors for whatever reason, whether new or replacement, and someone asks you, go get me some of these BNCs, but they got to work for 12G or they have to work for 3G, bear in mind that there's a whole new standard called an HD BNC, and that is not the same as a BNC. It doesn't mate with a BNC. It's half the size. It doesn't use the same tools, and it's very confusing, and we certainly didn't pick that name, but be aware that when you're getting into this new world of higher bandwidths and data rates, you've got multiple connectors that we're not used to working with. The mini DIN is another example. While it's been around for a while, it hasn't been very common until we got into the higher frequencies and the very high density patch panels. So you may see those around. We use fiber today almost everywhere in broadcast and AV and communications. From the most sophisticated facility we just did for one of the major networks, a 500,000 square foot facility. We built the entire SMPTE camera infrastructure, and it's just fiber from every piece of equipment to every piece of equipment. But you'll find fiber in somebody's house if they're a DJ on the weekends and they have a mixer or an audio console. There's fiber in that. There's fiber that allows you to extend HDMI signals for miles, as well as all the other types of signals for RF, for data, and control as well. Some of the reasons we use fiber, aside from the drastic improvements in attenuation and return loss, you've also got huge benefits in terms of size, weight, flexibility, cost, and also no issues with ground loops, which is a big plus. So looking at a graphic illustration of these numbers that we looked at before, you can see that of your standard coaxes that we have typically used for video, the RG11 being the largest one and the highest performance doesn't even get to line number 1 on the chart, where your single mode fiber pretty much goes off the end of the chart at any one of these standards. And looking at the size and the weight, you can see a typical digital audio cable compared to a single mode fiber, which is the little yellow line in the bottom. It's about 10 times the size, 20 times the weight, and the fiber is going to give you 100 times better performance in terms of attenuation and distance and bandwidth. So what is fiber? Basically a glass core surrounded by multiple layers or claddings and coatings. Now, the glass core, quite pure, by the way, in single mode is typically 9 microns. That's 9 millionths of a meter. The first coating that we're able to see with a normal eye is the 125 micron, and that's what we're going to be polishing and putting into the ferrules. You'll see that in a later slide. So the first question we need to ask if we need to buy fiber for replacement for a new project or specify is, do we want single mode or multi-mode? And here's what the difference is. Single mode used to be the more expensive version and the less common version. It has completely reversed, whereas almost everything we do in professional broadcast today is using single mode. The multi-mode, which used to be cheaper, is now often much more expensive, and you do find that in prosumer items, and you'll still find plenty of it around. The multi-mode, as you can see in the slide, has a much larger diameter core. In fact, it's 5 to 6 times larger. The standard sizes would be either 50 or 62.5 micron compared to the 9 micron for single mode. And what does this do? Well, the single mode being so narrow allows only one focused beam of light to go straight down the center, giving it amazing performance. The multi-mode, while still good compared to copper, is wide enough that it allows multiple paths, which is going to give you a much lower performance than the single mode. And this chart will show you the typical single mode, the 9 micron, compared to several different types of multi-mode, which brings us to the next question. If you need multi-mode, which multi-mode do you want? Do you want the older OM1, which is still around on many older pieces of equipment, but certainly we don't use it for new installations, or the 50 micron, which is the predominant one? OM4 is the most common at this point, which is a direct replacement for OM3. So you'll find lots of OM3 because that was the most popular for a number of years when there was a drastic growth in fiber equipment. So you find lots of OM3, you can put in OM4, and it's going to perform a lot better, and it shouldn't cost any more. You can see that the comparison in performance between even the relatively high performance OM4 compared to single mode, the single mode just blows it away by a huge factor. For those of us from the RF world coming from ham radio, we did everything in frequencies, and we always like to know what the bandwidth is for a particular frequency. So single mode in broadcast, we're typically using 1310 or 1550 nanometers, billionths of a meter, which equates to somewhere around 10 to the 14 hertz. And there's a name for it, but I don't know. Now let's get to the next question we need to ask if we're specifying fiber, or if one of your people comes to you and says, I need you to buy me some fiber. Well, if it's a multiple fiber cable, do you want a distribution type fiber, which, as you can see in this slide, has got multiple strands of a 900 micron typically coating, and those are the colored coatings. You can see the 125 micron cladding coming out of the ends. So there's bunches of these that can be almost any number with a strength member under a jacket. So distribution fiber is going to be lightweight, it's going to be low cost, it's going to be flexible, and it's going to carry a lot of fibers. The drawback is that when you have to terminate it, either you need to terminate it in a very protected environment because those 900 micron fibers are fragile. So in a splice enclosure or in the back of a rack where it's never going to move, or you need to sleeve it using what's called furcation tubing so that you can protect each one of those fibers and that you can terminate those fibers easily, as you see in this slide. Now, the other option is if you're going to be making lots of terminations and you're not running long distances, you can buy a cable with these fibers already individually jacketed. That cable is called breakout type construction. you can imagine that it's going to be a lot heavier, a lot thicker, and a lot more expensive. So it's a trade-off as to distances and numbers of termination points. One of the most common pieces of fiber gear that we use on a day-to-day basis are patch cords. They come in thousands of varieties. If you are responsible for buying patch cords, you need to know, first of all, single mode or multi-mode, simplex or duplex. What kind of connectors do you want? What kind of polish on the connectors? And then again, something that people don't always consider, what jacket size do you want? Because there are multiple jacket sizes. Oftentimes you're reading a spec on a patch cord and it's in the fine print and we don't even notice. We don't even know that there's multiple sizes of jackets. So something to consider, because a thin 1.6 is not going to hold up very well in a harsh environment, whereas a 3 millimeter for a small increase in cost will make a huge difference. We've got multiple types of fiber cable, both in distribution and in breakout type. One of the most common in our world in broadcast is called tactical fiber. Tactical fiber basically means that it is a rugged construction made to use outside and is supposed to hold up really well. The manufacturer is the one who actually states what the specifications are. Tactical fiber comes typically in 2 to 12 fibers. It comes in single mode or multi-mode and with a variety of other characteristics, but it's a great way to move massive amounts of data around. Another subcategory of fiber cable type is hybrid cable, and this is basically a mix of fiber, copper, could be power, data, video, you name it, all in one jacket, and we make hundreds of varieties of this pretty much to order. One of the further subcategories of a hybrid cable is a stadium cable, and that's made specifically for SMPTE camera applications where you have multiple cameras running from point A to point B to connect to CCUs or other patching equipment. And this cable allows you to run one cable for up to 4 channels, each channel being 2 single mode fibers and 1 set of copper for power and data. So it really drastically reduces the labor, and it allows any person with normal fiber termination skills to terminate SMPTE connectors, 2 SMPTE connectors through a panel that we would provide. The connectors for fiber come in many different types. This illustrates the 4 most common discrete connectors. These are single connectors that go on a single cable. As you'll notice, 2 of them are plastic, 2 of them are metallic. The metallic are going to hold up a lot better, much better outside than the plastic ones, which do not do too well if you step on them or roll a camera over them. Not that any of us ever do that. You'll also notice that the ferrule sizes are different between the LC, which is the small 1.25 millimeter, and all the rest, which are 2.5, and we'll talk about why that's important. The plastic fiber connectors come in either simplex, discrete 1, or a duplex, and the only issue with duplex is you need to know whether it's straight through or whether it's cross-wired, but if you get the wrong one, you can typically just open the clip and reverse them and you'll be fine. Another category of fiber connector is multi-fiber connectors, MTPs. They typically come in 12 or 24. They're getting to be more common. We've installed a number of these systems in the past year. They typically terminate, and this is the Neutrik design. There are other designs as well. The receptacle you see here mounts in a D-size hole, and you would purchase a breakout that would break out from the back into your 12 or 24 STs or LCs or whatever you needed. Polish options. We mentioned that patch cords come with different polish options. You may choose to do your own polishing. If you do, you have a number of different options. I don't want to go into the details of each one of these, but just be aware that if you are planning on doing fiber termination, you need to decide which one of these options is best for you and then proceed to that, getting that proper type of equipment for it. Looking inside of a SMPTE connector, this is the connector that is on most of the HD studio broadcast cameras today. You'll see that it's got a steel strength member. It's got 2 power conductors. It's actually, each one is a pair twisted into one. 2 datas, the red and the gray, and then the 2 single mode fibers, the blue and the yellow. This is a view from the inside of an actual connector, and you can see the steel strength member there in the middle. This is a front view of the LEMO SEMTI connector. Many of you probably have seen this if you have SEMTI camera equipment. The thing to notice here is that the ferrules are different from all of the other ones that we've looked at so far. These are 2 millimeter ferrules. And that's important because you need to buy specialized equipment for termination, testing, and cleaning. There are adapters available that will allow you to go from any of these SEMTI connectors to any of the standard connectors that you probably are familiar with. You go into a new broadcast facility today or an event venue, an arena, you're going to see fiber everywhere, not just one type, but multiple types. This is one of the panels we did. We did about 100 of these. You can see optical cons, MTPs, STs, and then LEMO SEMTI connectors in the bottom left, along with all of the normal copper and data that we've seen for a long time. Panels come in a wide variety of configurations and options. There's probably something that would be just perfect for what you would need, and we build these things custom, often at a lower cost than would be something readily off the shelf, and giving you exactly what you need and meeting your space requirements as well. Many, many different options. One of the features of construction that has been a huge help in getting SEMTI out into the field is the pigtail construction. And what that means is that you can buy a panel and you can use a pre-made SEMTI pigtail, that's a pre-terminated SEMTI connector, breaking out to a normal fiber connector. So any of your technical people who work with typical fiber can now install, move, and replace and troubleshoot the SEMTI connectors, which you don't normally terminate in-house. I like to point out that if you need to buy SEMTI camera cables, that the one on the left is a SEMTI camera connector, as is the one on the right, and you'd have a really hard time mating these two, and if you did mate them, it probably wouldn't do much good. So the one on the left is a LEMO, the one on the right is a Neutrik optical con. It's really a good idea to ask what type of camera connector do you have or do you need before you go ahead and buy one of these things, because they're not cheap. But if you do find yourself in a situation where you need to quickly convert from one to another, you can get pigtails and all other types of adapters that'll allow you to break these out to normal connectors. Another family of fiber connectors in the multi-fiber area are hermaphroditics. And these are typically used in military and industrial applications, but you do see them in broadcast sometime. And they're really cool because if you've just pulled a cable 700 feet in the middle of a field in the snow or in the heat, and you realize you needed the male, but you pulled the female, that's not an issue with these because either side mates to any other side. And one of the construction types in these connectors is called expanded beam. And I'm sure that all of you have always wondered what this means. So in a nutshell, your typical fiber connectors that we've seen up to now have worked with a direct contact of ferrules from connector 1 to connector 2, which results in a very efficient transmission of light. It also results in a very efficient transmission of dirt. So some very smart engineers came up with the idea of, why don't we isolate those ferrules, and why don't we use mirrors and lenses to transmit that light? And in fact, that does make the connector a lot easier to clean and less prone to that really mucked up dirt that Danny will show you. But it comes at a big price in terms of cost, size, weight, and complexity. I like to briefly mention optical con just because it's become a major part of our industry. The same people who make the XLRs and so forth have this pretty extensive line of fiber connectors that come either with or without copper. And please note that this connector you're looking at, which is a duo, has 2 fiber contacts in the rectangular area in the center. It's got 4 holes on the bottom. Sometimes there's copper contacts in those 4 holes, and sometimes there's not. They are in this particular one because this is a SMPTE standard cable that has to have copper. But if you're buying one of these things, you really need to know, do I want the one with copper for power or just fiber? Do I want a duo? Do I want a quad? Do I want a single mode? Do I want a multi-mode? And do I want the standard, robust, rugged version, which they call advanced, or the plastic version, which is indoor use only, called the light? One of the nice features is that they do have these protector covers that help somewhat in terms of protecting from dust and other contaminants. They've got these nice, robust metallic caps, and it's very easy for anybody to install the receptacles just by connecting typical LC connectors, as you see in the back. There are adapters for optical cons, just like as there are for the other LEMOs and SMPTE connectors, to pretty much let you go to anything else. Media converters are something that are available for almost any type of signal today, allow you to convert a copper signal, which may have had a very limited distance like an HDMI or some others, convert it to fiber, go for miles and convert it back, whether it's a single channel of video or whether it's a video wall or whether it's a full HD camera with all the controls as you see on the bottom. There are many different materials that we as a manufacturer use in manufacturing these cables. I just like to point out that just because the material fits into one of the generic names does not really give you all the information you may need in terms of, is this cable going to work in a particular environment, in a particular temperature, against a particular road hazard, for example. These are generic names that we all use. One of the critical things that we do as a manufacturer is balance the properties of the materials we use together with the performance that we need to arrive at a cable that's going to best serve our clients' needs. And one of the considerations that we have to balance, and it's a big one, is UL. And for those of you who haven't dealt with UL, haven't had the pleasure as we do on a regular basis, it is critical that you know in any new facility or a reworked facility or a replacement cable, if you need any type of UL rating, there's a drastic difference between, for example, a riser and a plenum. And I do not think that electrical inspectors look kindly upon any of us who put in the wrong type of cable and may require you to pull it all out after you've just spent the last 6 weeks putting it in. So bear in mind UL considerations. Braiding is one of these things we do in manufacturing. You saw that braider in the video, and it's a very basic technology, but it has a major impact on the performance of the cable. Right now you got 24 carriers, each one with 11 strands of 38 gauge. Anything that we do to change the gear ratios or the angles or the speeds is going to change not only the braid percentage, which we all know, but it's going to change the DC resistance as well, which can be critical in addition to the weight and the size and the cost of the cable. Many, many options for termination tooling. If you're going to do fusion splicing, I'm just going to briefly say spend a lot of money on the cleaver, because that is going to be the key to getting good fusion splices. One of the other questions we need to ask in purchasing cables, purchasing connectors, or patch cords: what type of polish do we need? You can see that there are 3 different ones on this slide. The UPC is the standard 50 to 55 dB back reflection, a really good number. If nobody says anything, it's probably UPC. Don't bet your life on it though. But angle performance, APC, angle polish, gives you the highest performance, 15 to 20 dB better. Sometimes you can tell by those connectors having green plastic housings, but you really need to ask, and you cannot reliably mate an APC to a UPC. You may see some PC polish connectors around from the past, but we certainly don't use them on anything new. And this is how APC gives you that better performance by cutting the fiber at an angle. You get a better back reflection performance. Fusion splicers are great. If you are thinking of getting one, be sure that before you get it, you carefully evaluate your options in terms of holders, fixtures, adapters for exactly the type of work that you're going to do, because there's so many different options. It's very easy to get something that is going to be less than ideal, but they do a great job when you use them properly. You can see the 125 millimeter fiber going into the F2 contact and the 2 millimeter ferrule on the lower left-hand side, and the blue being the 900 micron. So that's one of the LEMO contacts. Danny's going to show you briefly a really cool demonstration of some of the troubleshooting and testing we do. These are some of the things that we see in testing, and these are some of the things we see in repairing other cables. I just like to emphasize that the biggest three things we see are dirt, dirt, and dirt. So please keep your connectors clean, keep them covered with boots and caps and other protective things. Clean them all the time. We've got many different options in cleaning kits. Danny will show you how the click pen works. You'll need one for each ferrule size. Same issue with test equipment, hundreds of variations from very inexpensive to very expensive, and we'd be happy to discuss your needs in detail and help you select something. So we've looked at a little bit of the evolution going from almost what I call the coat hanger days of analog to the 3G and the 12G where we are today, and each one of these changes. And now we're looking at SMPTE standard of 24 gigabits. It's going to be very hard to use copper at anything more than a very short distance. So fiber is here to stay, and it's got great potential and a lot of great options. So with that, I'll turn it over to Danny, and I will let him give you a really cool demonstration.
We have no audio on you, Daniel.
Yellow.
There you are.
There I am. Okay. I forgot to push the little button.
Okay.
I is an engineer. I've been doing this all my life, mostly copper. Tail end of this has been fiber. So I've only been doing fiber like 25 years or something. Most of what I'm going to show you is going to be hands-on, meaning I'm going to actually point the camera down and do hands-on. I'm going to do a quick remedial look back at some of the things that Ben discussed, because I think they're important, because if you're not doing your own purchasing, or if you're doing your purchasing, there's key factors I want you to keep in mind. So I'm going to bounce through them rather quickly, because this is some issues we run into all the time when people are trying to order something to do a job, but don't actually collect enough information or get enough information, or it's how they convey the information that we've run into problems with. So I'm going to face the camera down and do a quick show and tell. We get lots of people who call us up and they're looking to buy patch cords, and the first thing out of our mouth is single mode and multi-mode. And the first thing out of their mouth is duplex. And we go, what? What do you mean duplex? They say, yeah, duplex. And we go, no, single mode or multi-mode. They go, duplex. Well, that's duplex, but that doesn't tell us anything about single mode or multi-mode. And it is, believe it or not, often confused with purchasing people to designate single mode or multi-mode. It doesn't. Simplex is one, duplex is two. I know it sounds remedial, but trust me, it is still a common error. The other thing we run into with patch cords or termination or assemblies is connectors. And I insist, if you're not going to write it out on a piece of paper, don't call me up and give it to me unless you're going to give me some phonetics. Why? Because LC, ST, FC, and SC all sound alike to me. and they all sound alike to everybody that you talk to on the phone. So if you're going to call me up and say STFCLC or SC, I'm going to go, well, do you mean Lima Charlie? Do you mean Sam Tom? Do you mean Sam Charlie's? Do you mean Frank Charlie's? Why? I've seen this happen hundreds of times. I've seen people buy hundreds of patch cords, get them onto a job site the day they needed to go live and find out they've got the wrong animal because Sam Charlie sounds a whole lot like Frank Charlie. Same way with UPC and APC for angle polish. So terminology is important. The Sam Charlies are great connectors for bend radius. Lima Charlies are great for small footprints. But ST, Sam Toms, your field connectors. And Frank Charlie's, whatever the variant, is the only threaded connector. There are other ones, but this is our bread and butter. And Frank Charlie's pretty much exist as APCs in the RF world, satellite uplink, downlink equipment, that kind of stuff. Difficult to mate, so I'd suggest you key them first before doing it. It's a two-handed mate, I always tell everybody. So Sam Toms are our basic bread and butter field connectors, while these two might exist in our patch panels. Then our other concern is designating what diameter. As you can see here, there are actually 3 different size jackets. There is a 1.8, a 2.0, and a 3.0 diameter. The connectors, am I not full screen? I'm going to spotlight video, maybe that'll fix it. 1.6 or 1.8, 2 millimeter, and 3 millimeter. If you're doing high density patch bays and you got 96 of these, definitely go 1.6, 1.8, or 2.0. But if you're making a patch cord that's going to go from a workstation to the wall or from a media cart, go with the 3 millimeter. You can get away with slamming these in a cabinet door once or twice, or even stepping on them. This stuff is going to break just by rotating the connector. There's just not a lot of strain relief in it. The other thing I'd like to discuss is what is tactical. Tactical is a polyurethane jacketed cable, whether it's 4 fiber in this case, 12 fiber, 6 fiber, and whatnot. While distribution and tactical actually have the same type of material inside. Distribution glass has got 4 900 microns in it. Tactical has 4 900 microns in it. But this one we'd stick running in the ceilings, running up into a rack and sticking in a box and fusion splicing tails on. This one, we would actually dress and break it out with furcation tubing, very unique term to the broadcast industry, but furcation tubing is what you would break this out to before terminating with individual STs. So now I know that we're going to probably collapse this around 7 o'clock. Normally I'd go into a big demonstration about how to field terminate an ST connector with epoxy polish. But I think that the more useful would be is to discuss, this is what you need to know to buy it. But what you need to know to maintain it is how to clean it. I am a big fan of a video scope. I think everybody needs to own a video scope. Handheld scopes are fine for passive cleaning, but in order to do LEMO connectors, Neutrik connectors, any type of contacts that are recessed in a receptacle, you need to own a video scope. Video scope plugs in with USB, comes with multiple tips for multiple different kinds of fiber contacts, the 2 millimeter, the 2.5 millimeter, the 1.25 millimeter, both receptacles, angle polish, you name it, you can put it on. Then you get to look at the glass. And I'm going to bring a picture of the scope up on the glass. Okay, besides a little bit of schmegma. That is the glass. Let me give that a quick wipe down. Where are my chem wipes? Right here. I use the same parts for demonstration over and over again. Okay, so what we have here is the 900 micron core, and we've got the cladding built out to 125. Remember, we don't touch the 9 micron core. The core would be way too small. It has to be built up to be resistive. And then you got the zirconium way out on the end, and then you got some sort of mosquito or something on the glass. Now, what I'd like to point out is it doesn't take much to schmegma this up. So I'm going to back this off and show you a very realistic event. I'm simply going to touch the surface of that contact once and show it to you again. And then I'm going to say why you need to be religious about cleaning it. Okay, fortunately, a big piece of dead flesh or whatever didn't land across my 9-micron core. Keep in mind, we're talking millionths of a meter. It doesn't take one. If any of those globules had gone across my core, that would have cost me about 6 dB of attenuation. But the worst thing that's going to happen now is if I were to mate this to a receptacle, I would transfer all of that, okay? Like the illustration showed. All of these connectors, other than expanded beam, are positively engaged, and all these connectors are spring-loaded and force these two contacts to touch each other. So it is imperative that you learn proper cleaning techniques. I'm a big fan of string cleaners. String cleaners basically ratchet. They're literally like dental floss, roll of string, snap, snap. On this case, snap, snap. I'm going to show it to you again. Now, there's other simple ways to clean it, chem wipes, alcohol, and whatnot, but you'll get 90% of it just with a quick string clean. Yes, that probably needs secondary wipes, but mating or cleaning something before you mate it is very, very important. Stickler makes several different cleaning tools, and I'm going to show you this one because it's my favorite. I call it the 25. They're color-coded, different sticks. This is sort of the reverse Q-tip design. It's a synthetic material inside of a tube that allows me to rub it against the surface of a contact, sort of brooming it, rotating it one direction, and then pulling it away, and I will actually lift off the schmegma. The other benefit of this design of it is reaching inside a connector, okay? In this case, you've got the LEMOs. The female jack is an exposed contact, but we wouldn't be able to view that with a standard handheld scope. We could only view that with a video scope. And it gives us the ability to reach down inside and actually rub the surface of that contact, which you would inevitably have to do, or use a one-click cleaner, and of course, one specifically designed for 2mm ferrules. Click, click. Now on the boy, you would need a removal tool. Why? Because it houses the alignment sleeves. They're threaded on, and the tool, very inexpensive tool, is threaded for it. It basically rolls down over the top of the alignment sleeve and pull. Now this alignment sleeve has a piece of zirconium in it. It's C-shaped. And believe it or not, owning a few extra of these is imperative. Why? Because when that C breaks, that C shape, it's soft like a seashell inside, and it keeps those two alignment sleeves or two contacts properly aligned. If it breaks inside, it's worth 20 dB of attenuation. And every year I get a few dozen cables back that all I'm replacing is that, when they didn't know, and they didn't own the tool. So I believe it's imperative that you own it. Now, simply by removing that alignment sleeve, I can use the stickler, 25, reach down inside, rub the surface, or actually reach through, as I demonstrated before, and use a one-click cleaner, snap, snap. Then reinstalling it's exactly the reverse of the operation. The alignment sleeve threads onto the tool. It reaches down inside, snap, unthread, voila, you are done. Now, the other aspect of the camera connector, or other brand of the camera connector, is LEMOs. So most of you will have the SEMTI, LEMO, excuse me, and the other half of you are going to have Neutrix. Neutrix are shuttered connectors. The LEMO world is male-female. There's actually plugs and jacks. In the Neutrix world, there are only plugs. You can only put two of them together with a coupler. So you've got receptacles that will be mounted on your devices, and you've got plugs that are mounted on the cable. Those are behind shutters. So in order to get contact with them, you would have to own either a specific tool. This is a fixture manufactured by Neutrix that slides down on it. That actually, and Stickler does make a cleaner that actually reaches through that tube to touch the surface of that contact. But if you didn't own the tool, you can simply take the head off, and I'm a big fan of that. Retract the spring, retract the wavy washer. The back nut has teeth, so you have to do this. Simply rotate that back nut until it clears the threads and pull the head off. Now you have exposed contacts, a pair of LCs. Again, we could use the basic tool. Rotate, rotate, rotate to clean the surface of the contact, or a specific click cleaner that works on the individual LC connectors. Snap, 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 snap. Then, since you own the video scope, you can switch the die over to a 1.25 millimeter, plug it in, look at it on the monitor, and know that you've actually cleaned it properly. So then reinstalling the head, large polarizing key, large polarizing detente, name at the top, slide it directly on, seats. Now bring this up. It's a couple of snaps, let's say 3 to 5 pounds. Why? Because it's spring loaded. So, and then once it's seated, we back it up to make sure that there's no undue pressure on the springs, and then always verify it that it seats. Do not throw this on a truck and send this out into the field, or leave this for a camera guy to find out that it doesn't mate properly anymore, because periodically it will. So the receptacle is basically a pair of LCs in the rear. So this exists on your CCUs and cameras. Getting access to it, I would suggest you remove them one at a time and do the exact same operation. Video scope them, clean them, snap, snap. You can use the exact same tool. I'm a big fan of this, even though it was made for larger ferrules. It works fine on the mini ferrules, the same way with the one-click cleaner. So, and then reinsert it. The Neutrik world is an A-B world. That means A goes to B, B goes to A. The LEMO world is AA. So it is imperative that you keep track of the glass and that it goes into the position, A or B, that it was designated for. Crossing it over, it's simple to cross back, but it will not get a picture. So there is also OpticalCon Quad, which is a 4-fiber version, and multi-mode. So they are color-coded. Quad is a 4-position. I can see there, or show you there. There's 4 contacts behind it. The multi-mode version, which is a black insulator, is the same as the single mode version. However, these are glass only, as you can tell by the diameter, this only being 6 millimeter, and that being 9 millimeter, the SMPTE version. But knowing that this is single mode because it's blue, that's single mode because it's blue, that's multi-mode because it's black. And if either one of these were green, they would be APC, that's angle polish. Knowing this is important, especially if you rent a bunch of stuff and it shows up and it's not the color you were hoping for. Very recently happened to one of our customers. So, lastly, I'd like to show you an interferometer. Why? Because we paid a small fortune for it and we had to have one in order to proof our polishing techniques. So an interferometer is something that measures in 1/1000th of 1/1,000,000th of 1 meter. And they cost us about as much as a new car. I'm going to switch to another camera perspective, which is my Henry. As soon as I pull up the software, I forgot to load it, and show you the surface area of a contact. Come on. Come on. It always lets me down. Okay. Hopefully everybody sees that. That is the core of the glass. That is the radius of the contact. This has been polished to a telecordia standard. We are actually looking at 1/1000th of 1/1,000,000th of 1 meter, different aspect ratios in a 3-dimensional representation. The importance of maintaining proper polish is that you can easily pencil a contact as well as give it the proper radius. And if somebody over polishes a contact that actually turns it into a pencil versus that type of radius, they will cause undue stress on the contact area, the surface, literally the surface of the glass. During multiple matings, they'll actually damage each other. So if we don't all agree to a particular radial standard and we don't all try to maintain it, basically we're going to keep plugging camera cables into each other's equipment and slowly damage each other's equipment. This is the only place or only chance I have to show you this, and it's rare that you'll ever see a contact blown up to this proportion. But that's what I wanted to show you, and I'm going to end it there and take any questions if anybody has any.
Fascinating. That was absolutely fascinating.
I'm sorry I sort of seemed like I was rushing, but you did say that you end at 7 and I sort of have to leave. So
Absolutely. So anybody have questions for Daniel or Ben?
Yes, hi, this is Renard Fiscus. Do you have a list of all the gear that you used?
I'm sorry, can you repeat that?
A list of all the gear that you used?
No, but I could type it up. I didn't even demo the polishing aspect of it, but yes, there is, every part here, there's a part number for, yes, but I don't actually have a list. My normal presentation is over an hour long sometimes, and there's 20 other items that I didn't show, so I've never actually created a list. But if you give your name to Ben, I am sure we'll create a list and give it to you.
Thank you so much. I'll find Ben.
Okay.
I'm right here.
Anybody else have any questions or comments about anything that I just did?
The quiet group. Well, I will say that that whole presentation was fascinating to me. I'm in the audio business and not necessarily video, and I learned an awful lot here. So,
but there's more and more of this in audio. I'm telling you.
We're seeing it.
I'm racking stuff. I use that quad connector in quite a few stadium presentations. But I'm always here, meaning, you can give us a call, email me, whatever. So.
All right. And Ben, thank you for being available for us at around dinner time. We've found that these evening meetings get a better turnout than the midday ones. So thanks for being flexible on the time.
Well, thank you for inviting us. It was really a great pleasure to meet everybody. There was a couple names that look familiar to me, but again, it's been a very challenging year, and this is one of the things that's helped us to get in front of our customers and keep in touch with the whole industry. So we look forward to seeing you all in person though soon. And again, as Danny said, if anybody's got any questions later at any point, please give us a call, shoot us an email, and we'd love to hear from you.
Thanks for joining us. Please remember to subscribe to SBE 15 New York City.